Dear students, software testing methodologies. Now we're going to start about the public question papers. It is something about the public question paper. In this public question papers, it is unit 1. That is, so we're going to see the questions in unit 1. Now, the first question, the most important first question from university examination tablets is in first unit. That is, discuss the consequence of that is what is meant by consequence of bugs. This first one is importance of bugs. The importance of a bug depend on frequency, correction cost, installation cost, and consequences. Okay. The importance of a bug. The importance of a bug depends on the importance of a bug depends on frequency. Number one. Second one is correction cost. Second one is correction cost, and the third one is installation cost and consequences. And consequences. Okay. And consequences. Frequency. The rate at which bug occurs. Frequency is the rate at which bigger bug occurs. More frequently, it occurs more frequently. Correction cost. Correction cost is the cost that occurs during the error correction process. Installation cost is the cost of different application installations. Consequences, it is the effect of a bug. How bugs affect us consequences, that is various consequences. The consequences measured in terms of the human rather than in terms of machine. The consequences measured in terms of human rather than in terms of machine, because human right programs. The various bug consequences are as follows. First one is mild. These consequences results in an incorrect, wrongly aligned output. Mild means these consequences result in an incorrect, wrongly aligned output. Moderate. This consequence affects the system performance. They are annoying. The performance of the system degrades. So this annoying, what it will do is the performance of the system degrades. Disturbing. This consequence cannot execute the correct transactions. Disturbing means this consequence cannot execute the correct transactions. Disturbing is serious. Serious means it losses transactions. Very serious. It is converting deposit to withdraw. That is nothing but the very serious. Extreme. There is also a transaction problem. Intolerable. When a large data is corrupted, the corruption is not easily discovered. In such situations, shutting down the system is called as intolerable. Intolerable means when a large data is corrupted, the corruption is not easily discovered. In such situations, shutting down the system is called as intolerable. Catastrophe. This consequence is system fails, hence shut down the system. This consequence is system fails, hence shut down the system. Infectious, a system that does not fail but corrupts the other system results. Infectious means a system that does not fail but corrupt the other system results, that is called as a infectious. Next, flexibility, severity, flexible severity rather than absolutes. If there is a bug, then the bug is flexible. If there is a bug there, then that bug is if there is a bug, then the bug is fixed. It depends on correction cost. Correction cost. First one is correction cost. It is a cost of correcting a bug. Then second one is context and application dependency. The strictness of a bug and bug depends on context. Creating culture dependency. The important depends on the creators of the software. User culture dependency. The important depends on user culture. The software development phase. Severity, the strictness depends on development phase. Severity, that is strictness, depends on development phase. Then the nightmare and that nightmare list and when to stop testing. Nightmare means some specific bugs. To quantify the nightmare, a workable product the procedure is used. This first one is history or works to software nightmares. Second one, convert the consequence of each nightmare into a cost. Third one, order the list from the costliest to the cheapest. based on your experience, measure data, position the types. Fifth one is for each nightmare disturbance. Sixth one is rank the log types. Seventh one is a design test based on your knowledge and design quality assurance using methods. If a test is passed, then some nightmares go away. If a test failed, a nightmare is possible. Next, ninth one, stop testing when all nightmares shown to be unimportant. Next important question from question papers is explain path selection and path testing criteria. How they affect testing. Fundamental path selection criteria, that is path selection. There are many paths between the entry and exit of the routine. Path selection is the selection of a optimal path. Path selection means the selection of a optimal path. The selection of a optimal path. Path selection is the selection of an optimal path. If a routine contains decisions or loops, then there will be more number of paths. For example, every decision double the number of paths and every loop multiplies the number of paths by number of passes for the loop. Complete testing involves three. Number one, exercise every path from entry to exit. Two, exercise every statement at least once. Three, exercise every branch and case statement in each direction at least once. In each direction at least once. In each direction at least once. If one is followed, then two and three are automatically followed. If one is followed, then two and three are automatically followed. Two and three are automatically followed. Two and three are automatically followed. If one is followed, then two and three are automatically followed. Here, if one is followed, exercise every path from entry to exit is followed, then two and three are automatically followed. That is, exercise every statement at least once is followed, and exercise every branch and case statement in each direction at least once is followed. So, example one, see here, if x LT0 is less than 0, go to 200. X equal to x plus a, then suppose if it is a true case, x equal to x plus a, false case, it goes to 200, again x equal to x plus a. So S condition, it goes to 200 and x equal to x plus a count and it go to 300. When false direction, x equal to x plus a and go to 200, again x equal to x plus a. That means x equal to x plus a is going to calculate about 2 times. Okay, that means x equal to it takes about the x plus 2. It is about the round actually. So we get the both. So true case only you have to consider. Then second one is if x LT0 go to 200, that means 200 is x equal to x plus a. 200 is x equal to x plus a. In no case it goes to x equal to x plus a. So in both cases it goes to x equal to x plus a. You can consider. Okay. See, for x is less than 0, x is less than 0, it goes to two case, it goes to 200, and x is equal to greater than 0, greater than 0 means it goes to no condition, goes to 200 and x equal to x plus a. But you have to consider only about the true condition, not about the false condition. In false condition, you have to consider wrong. Then next one is next one false condition. It comes to the if we go to 200 false condition goes to 300. False condition goes to 300. False condition goes to 300. Okay. So no case it goes to no case. Yes case it goes to 200. Then from 200 come out. Okay. Suppose if x is false case also it goes to 200. False case also it goes to 200. So true case it goes to 200. False case also it goes to 200. But you have to consider only one. That is a true case it goes to 200. So that's why you cannot consider about the false condition. That is x greater than 0. So example 3. If x 200, 150 and 150. That is 150 x equal to x plus a, 200 x equal to x plus a, 300 it is continuing. But it is 200, 150, 150. 200, 150 and 150. 300 it is continuing. So less than 0 it comes to 200. So equal to 0, it comes to 150, greater than 0, it comes to 150. But if it is equal to 0, it is 150, x equal to x plus a. Again, it comes to x equal to x plus a, that is x equal to x plus 2a. So x equal to 0, x greater than 0 cannot be considered. Only you can consider x less than 0, then it comes to 200, then x equal to x plus a, that is correct. Like that you have to consider. Okay. Next topic is path testing criteria. Very important task is path testing criteria. Path testing P50. In a program, if all the available paths from an entry to exit are thoroughly tested, then it is called path testing. In a program, if all the available paths from an entry to exit are thoroughly tested, then it is called path testing. If we achieve this, then we are said to be 100% path coverage. But it is impossible or very difficult to achieve this. It is represented as C1 plus C2, where C1 is statement coverage and C2 is branch coverage. Statement coverage C1, C2 is branch coverage. The next statement testing P1. In a program, if all the statements are executed at least once, then it is called statement testing. In a program, if all the statements are executed at least once, then it is called statement testing. If we achieve this, then it is called 100% statement coverage or 100% node coverage. We denote statement coverage as branch testing P2. In a program, if all the branches are executed, all the branches are executed in each direction at least once. In each direction at least once, then it is called branch testing. P2, it is called branch testing P2. If you achieve this, then it is called 100% branch coverage or 100% lead coverage. We denote branch coverage by CP. Okay. Now, next question. Next public question. It is most important question. What is control flow graph? Explain how to generate control flow graph. The control flow graph is a graphical representation. The control flow graph is a graphical representation of the program control structure, which does not deal with the internal structure of the process. It does not deal with the internal structure of this process. Converting flow graph into flowchart. Converting flowchart into control flow graph. Here we use Fortran program design language PDL. So the code is one input xy, z equal to x plus 5, v equal to x minus 1. So z greater than z equal to 0, go to Sam. So Jai is z equal to z minus 1, Sam z equal to z plus v, 5. Then next 6 1 is loop for equal to 0 to 0 to uv z plus v, z plus v. 7, if u equal to 0, go to Jai, z equal to z minus 2. 8, if z equal to 0, go to L, u equal to u plus 1. 9, next u. So here vu minus 1 equal to vu plus 1 plus u minus 1. Next 10 L, v u plus u, v u plus uv equal to u plus v. 11. If u equal to v, go to Jai. 12. If u greater than v, then u equal to z, z equal to u. And this is the code. Now we are right about the flow chart. First, the flow chart for the above code is given by input x equal to y, z equal to x plus y, v equal to x minus y. If z greater than or equal to z, go to Sam. Go to Sam. S condition, go to Sam. Okay. Then otherwise, go to Jai. Go to Jai. Then after Jai, z equal to z minus 1. After z equal to z minus 1, again goes to Sam. After Sam, it goes to the u z equal to z plus v. Then next for loop. For loop initially u equal to 0. Loop going to be start. When loop going to be started, then vu equal to z plus v into u1. U equal to z plus v into u. To vu comma u equal to z plus v into v. Both. Then next is 7. Vu equal to 0. Then go to Jai. S condition, go to Jai. Then no condition. Z equal to z minus 1. Then z equal to 0 if go to L. Z equal to 0, go to L. True condition, go to L. False condition, u equal to u plus 1. Then we're going to find about the whether u equal to z or not. If u equal to z, again it increases about u equal to u plus 1 and go to the loop. That is repetition. Okay, repetition. Then otherwise, if condition false, then automatically it come to the vu minus 1 equal to vu plus 1 plus uv minus 1. Then after that it goes to the L. Then L means vu plus uv equal to u plus v. Then next, if condition u equal to v, go to Jai. Then no condition if u greater than v. Then S condition u equal to z, no condition z equal to u, no condition z equal to u. It comes to the end. Now for this flow chart, so what you have to do is all the process, whatever whatever there are the different process. You write about process one, process two, like that. For example, take about the first process one. That is, process means in between decisions, in between junctions, in between decision or junction or decision, starting or decision. So in this Z equal X plus Y, Z is equal to X minus Y, both are process one. Z equal Z minus one, process two. Z equal Z plus V, U equal 0, process three. This both process 4, then process 5, then process 6, process 7, then process 8, process 9, process 10, and process 11. So that means here you can represent like this. Both can be considered as process 1, and this Z equal Z minus 1, process 2. Then here it is. So here it is next. Z equal Z will process 2, then Z equal Z plus will process 3, and this both process 4, then process 5, Z equal Z minus 1, process 6, U equal to U plus 1, process 7, U equal to U plus 1, U equal to U plus 1, process 7, process 7, process 7. Next, process 8. Process 8 is VU minus 1 equals so and so. Process 9 is U plus 1 equals U plus V. Process 10 is nothing but U equal to Z. Process 11 is nothing but Z equal to Z plus V. Z equal to Z plus V. Z equal to Z plus V. Okay. Now this one in very short you can write like this. In very short you can write like this. Okay. So here how we can identify about the decisions and junctions. Here how you can identify here how you can identify about the decisions and junctions. One incoming to outgoing is called as a decisions. Two incoming, one outgoing is called as a junction. Say here one incoming to outgoing B1 decision. Here two incomings and one outgoing J1 junction. Then here two incoming and one outgoing junction J2. Here two incoming, one outgoing junction J3. Here one incoming to outgoing decision D2. Here 8 case one incoming to outgoing decision D3. At 9 one incoming to outgoing decision D4. At 10 two incoming, one outgoing, that is junction 4. Junction 4. 11 one incoming to outgoing decision D5. Here one incoming to outgoing decision D6. At 13 is two incoming, one outgoing, that is junction 5. Like that you can remember about the junctions. Okay. Then from here, whatever here the values you can represent here. One is nothing but input that's all. Then at 3, what is there at 3? If Z greater than or equal to 0, specify Z greater than or equal to 0. At 4, what is there? 4 joy, specify joy. At 5, what is there? Sam, specify Sam. 6, what is there? Loop, specify loop. 7, what is there? That is VU equal to 0, V of U equal to 0, specify. Then next 8, at 8, Z equal to 0, specify Z equal to 0. Then at 9 is nothing but you have to check whether U equal to Z or not. So then if it is U equal to Z, then it comes to the 10. If U is not equal to Z, then goes to 6. You know about that one. So that's why here you write U equal to Z. At 10, they specify about the L. At 11, you have to check condition if U equal to V. 12, if U greater than V. Okay, like that we can specify about this is nothing but the simplified control flow of implementation. Okay, this one in short you can specify like this. Now, what are the different kinds of loops? Next, very important question is what are the different kinds of loops? Repeated loop in a path if any node is repeated more than one time. In a path, if any node is repeated more than one time, then it creates a loop. There are three types of loops. One is called as a nested loop. A loop within another loop is known as nested loop. These nested loops are complicated. Because of this complexity, it is very expensive to test the path. So loops always creates about the complexity. In these figures, both figures, see here 1, 3, 4. It comes again 3, 4, 2, 3, 3, 4, 2, 3, like that. Here it creates about a loop. Similarly, 3, 5 to 3, 3, 5 to 3 creates a loop. So outer loop and inner loop. Here in second figure, inner loop is 4, 5, 4, 5, 4, 5, 4, 5. Outer loop is 3, 6, 3 to 6, 3 to 6, 3 to 6. So inner loop and outer loops. Then P. concatenated loops. Next B is nothing but the concatenated loops. If there are two adjacent loops on the same path, if there are two adjacent loops on the same path, such that an exit of one loop may be an exit of another loop. So one exit is entry of another loop, then the loops are known as concatenated. Exit is known as one input of the loop. One exit is one input, one exit is one input. That's all. The loops cannot be on the same path, that they are not concatenated and can be known as individual loop. If the loops cannot be on the same path, then then they are not concatenated and can be known as individual paths, individual loops. So here first one see the one output, that is 3 4 output is nothing but 5 6 input. That's why it is called as a concatenated loop. Then horrible loops. If the loop cannot be nested, if the loop cannot be nested or concatenated, if the loop cannot be nested or cannot be concatenated, then the loops are said to be horrible loops. Horrible loops are complex, so very difficult to test. Hence, horrible loops must be avoided. So, like this, there is not a proper way. Okay, so one output, another input is not like that. Here, this is also complicated. So here you cannot identify, okay, how the uniformity of between about different loops. So where it's going to be create the loop 3 to 6, then 6 to 7. That's all. Then where is the loop? Loop cannot be created properly. 3 4 5 7. 3 4 5 7. 3 4 5 7. That's all. 3 4 5 7. That's all. So where is the loop totally? So making loops are very complicated here. Okay, that's why they call as a horrible loops. Horrible loops. Explain the model of testing with its sketch. Next question is model of testing. It's also very important. Model of testing with its sketch. The project first. The project application. It is a real-time system that provides responses to user requests. Application is a real-time system that provides responses to user requests. Staff. The programming staff consists of 20 to 30 programmers. The programming staff consists of 20 to 30 programmers. Schedule. The project will take 24 months. Specification. This is functional specification without design knowledge. This is functional specification without design knowledge. Without design knowledge. Acceptance test. The system will accept the test. Personal. The staff is professional and experienced in programming. Standards. Test standards are followed. Objectives. The system and similar systems have 75% of code is common. Source. 1/3 of the code is new. 1/3 extracted from the previous. 1/3 is reinvested. Sources. 1/3 of the code is new. Sources. 1/3 of the code is new. 1/3 is extracted from the previous, and 1/3 is reinvested. History. One programmer will quit before his components are tested. Another programmer will fire before testing begins. That is history. See the diagram here. The model world. The world is nothing but the environment. The model world is nothing but the environment model. Unexpected is about the expected outcome. Here, program is there, program model is there, test is there. So in this test program model and the program can get their bug model. So nature and psychology, from nature and psychology also you can get about the bug model. Okay. Now overview. There are 3 models. One is model of an environment. There are 3 models. One is model of an environment, model of an environment, model of an environment. Then second one is program, and third one is bugs. Second one is program and third one is bugs. Second one is program, third one is bugs. Okay, now from this model to create. Okay, so one is model of an environment, other one is model of a program, and the last one is model for expected bugs. From these models we create a set of tests which are then executed. Okay, from these models, we create set of tests which are then executed. A, environment. The environment is a computer that is a combination of hardware and software. Environment is a computer that is a combination of hardware and software. Online system environment is a communication lines, terminals, and operators. Online system environment is communication lines, terminals, and operators. Environment also includes all application programs interact with operating system. Environment also includes all application programs interact with the operating system. Interact with the operating system. The program, B is the program. Most programs are too complicated to understand in detail. Most programs are too complicated to understand in detail. So simplify the concept of program to test. So what is required? Simplify the concept of program to test is required. C, bugs. The bugs are nice and logical. Bugs are nice and logical. A bug found within a component affect only that component. The language, that is syntax, eliminates syntax errors. Mostly by using the language syntax, okay, can eliminate about the syntax errors. A corrected bug remains corrected. Easy bugs can catch. Tough bugs need methodology and technique. Actually, there are different types of bugs now. A corrected bug remains corrected. Okay. Easy bugs can be catched easily. Tough bugs need methodology and techniques because tough bugs you can't easily catch. The testers are better at test design, and the programmers are better at code design. So, tester, where you can find about mostly about the testers. The testers are better at test design. So their testers are better at test design, and the programmers or whoever the programmers, and they are better at the code design. At the code design. Test. Next one is tested. Inputs prepared, outcomes predicted. Test documented. Inputs are prepared first, outcomes predicted, test documented, and results is observed. All these are subject to error. All these are subject to error. So error may need to review the test. Error may lead to revise the test because the testers are themselves in an environment. We have a mental model of testing. In this case, instead of revising the test, we have to revise that mental model. Mental model should be revised. Testing and levels, that is different types of testing. The different types of testing are unit testing. A unit is smallest piece of source code, that can be tested. A unit is smallest piece of source code that can be tested. A unit is usually the work of one programmer and it consists of hundreds or fewer lines of code. So for the first one, that is unit testing. A unit is smallest piece of source code that can be tested. A unit is usually the work of one programmer, and it consists of hundreds or fewer lines of source code. Fewer lines of source code. Unit testing is the testing to show that the unit does not satisfy its functional specification. Unit testing is the testing to show that the unit does not satisfy its functional specification. The unit does not satisfy its functional specification, and its implemented structure does not match the design structure. Implemented structure does not match the design structure. Whenever test get such problems, we say that there is a unit problem. Then second one, B, component testing. A component is an integrated aggregate of one or more units. A component is an integrated aggregate of one or more units. A unit is a component. A unit that calls subroutines is also a component. A unit is a component. A unit is a component. Okay, a unit is a component. A unit that calls subroutines, that is subroutines. Okay. So it can also a component. From this, a component can be anything from a unit to an entire system. Component testing is the testing to show that the component does not satisfy its functional specification. Component testing is the testing to show that the component does not satisfy its functional specification and its implemented structure does not match the design structure. Implemented structure does not match the design structure. When our test such problems, we say that there is a component. Next, integration testing. Next one is integration testing. It is a process of combining smaller components to produce larger components. It is a integration testing. It is the process of combining smaller components to produce larger components. Integration testing is a testing to show that even though the components are individually satisfactory, the combination of components is incorrect. This is the most important thing in integration testing. Integration testing is a testing technique to show that even though the components are individually satisfactory, the combination of components, combination of components is component the combination of components is incorrect. The combination of components is incorrect. For example, AB. For example, A and B are components. That give testing successfully. That gives a testing successfully, but failed when integrated. For example, A and B are components that give testing successfully, but fail when integrated. Then B, system testing. A system is a big component. It is a black box testing and functional testing. System testing is done either on the whole system that is integrated or only on the important parts of the system. The role of models. Here we create mental model for testing. Each model is used until we accept the behavior correct or until the model is no longer sufficient. Unexpected test results, revision of some mental model. Unexpected test results is revision of some mental model. The revised model may be more detailed. Okay. So again, a few important questions from university paper. I explained for unit 1 today's class. Tomorrow I'm going to explain about the unit 2 most important questions from previous class. Okay, thank you.